Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Number of dice rolls with targeted sum or target sum. Yeah, I am now back in New York. I think I'm still jet lagged. Well, maybe not jet lagged, it's not the right term, but I've been sleeping way erratically, the schedule. But now that advent of code is done, and I hope you enjoyed it. My videos are done there as well. I am going to start taking requests for problems that I haven't done before. So if you have problems you want me to kind of take a look at Leetcode, I like to do problems that I haven't seen before. So, and if I have a video on them, then that means I've seen them, obviously. So let me know in the comments, let me know in the Discord or whatever. I'll try to do one a day, just like an extra one, just to kind of keep my fingers in shape and so forth. So yeah, let me know in the comments. And of course, I have to not have done it before, otherwise it's just me. I mean, I do enough problems that I've already done, like this one. So yeah, let me know in the comments. But hope everyone's having a great holiday. New Year's coming, 2024. What a time, huh? But yeah, anyway, today's problem is number of dice rolls with target sum. You have n dice. Each dice has k faces numbered from 1 to k. There's a mod, so let's do the mod, so I don't forget the mod. Okay, you're given n, k, and target number of possible ways to roll the dice so that the sum equals to target. Okay. Yeah, I mean, this also feels like a very binomial thing, but what is k? K is just the number of sides. So that means that k doesn't change within the scope of a problem, but you can basically, and I guess this is what its target, right? Is it the number of? Oh yeah, obviously if you return a mod. Is this binomial as well? I guess so, right? What is n? N is only up to 30, so that's probably even... The target's a little high, right? Oh, no, because n times k is... Like, some of these are just impossible, right? Okay, well... yeah, but in any case, so... I guess we're getting a dynamic programming week, or at least a couple of problems. And as I say, as I always try to do with dynamic programming, the thing with dynamic programming is that you're trying to represent a problem in terms of smaller subproblems. And usually they're smaller so that you get a sense of direction and make it a DAG, right? Dynamic programming only works if you have a DAG on the implicit graph, or another way of saying it is if you don't have a cycle. Though there are fun ways to get around those, at least on hard, maybe not on Leetcode level though. I don't know, maybe they'll come up. But in any case, and they're more mathematical. But anyway, but yeah. So basically, so that's a very like mathy way of saying it. But the way that I would like to think about dynamic programming is just keep on asking yourself smaller questions, right? For example, maybe you have a target is equal to 7, n is equal to 2, then you could say, oh, what if n is equal to 1 and target is equal to 6, right? And then you kind of basically have all these pieces and then you build it up all together. And with dynamic programming or memorization, there are usually, two ways to do it. And I think in general, in my videos, I usually teach the top-down one because I think it's easier to say. The direction of of solving it is pretty straightforward, but definitely if you're weaker and the other one bottoms up, then definitely practice that as well. The idea behind bottoms up is that in a way it is kind of like implicit versus explicit with respect to getting your topological sorting graph sorted, so to speak. Meaning that, okay, so basically if you need to solve A, you need to solve another B first, and then the difference between memorization and dynamic programming, bottoms-up dynamic programming, is that in top-down you're going, okay, I need to solve A, here are the things that I need to solve before I can solve A, and then you just go out and get them one at a time. Where bottoms-up is, okay, I'm going to solve these things in this order, and by the time I get to this thing, I will already have everything I need, right? Kind of like that. I mean, I'm using it in maybe straight English, so it's not quite as precise, obviously, but that's basically the idea that I would think about. In any case, I mean, this is to be frank, a pretty textbooky problem. Yeah, so that's basically the idea. It is a very textbooky problem, so you should definitely know how to solve this if you're prepared for an interview. That's basically what I'm going to say with that. Okay, so count, spell count correctly. We have n, maybe you could even say, ooh, how did that? N left and target left or something like this, right? And then if n left is equal to 0, then basically you're basically saying I have no more dice rolls. So if target left is equal to 0, we return one way to do it. Otherwise, we return 0. And yeah, and you can also maybe do a shorthand with if target left is less than 0, you can return 0, because obviously there's no matter how many dice you have left, you cannot, go up, right? And then now the total, naming and stuff, so you use your imagination. But yeah, maybe I should do a video on mod functions and mod spaces and stuff like this. I feel like people ask me this a lot, or at least get a lot of it wrong. But yeah. Right, so then now this is what we want to do. So basically each of these faces can do k things, right? So then now we simulate, okay, what if we roll what if we roll I, right? Then when we roll I, then we now have, and we have one fewer die, and we just minus I from the target. And that's pretty much it, really. You can add some mod stuff in here as well if you like, but yeah. Of course, this is going to be too slow. That's the point of memorization. Oops. But yeah, of course, without memorization, oh, this is definitely a timeout, which is probably good, and that I can show you. This is going to time out because it branches k times for each one, so it's going to add up very quickly and stuff like this, though. Yeah. And so the thing you add to it is memorization. Again, the thing to notice is that for every input, or every same input that you get, you have the same output, right? So it's a deterministic function given the hidden variable k in a way too, so be careful with that statement per se. But yeah, then we just could, we could remember what we have because it's going to give us the same answer every time. So yeah. And that's really pretty much it. Now, if this thing is in the cache, that means that we already saved it. We just return the answer. Otherwise, we calculate the answer. And once we calculate it, let's save it down. And that's pretty much it. Yeah, hopefully. And I think that's the max. I mean, it is roughly close to the max. So, 1365 day streak. That's 1,000 days more than 1 year, isn't it? Huh. Or something like that. I don't know. Anyway, yeah. So what's the complexity here? Well, with dynamic programming, the way that I always think about it is just the number of. So total time is just equal to number of inputs times time per input, right? And number of inputs is just n left can obviously be from 0 to n, so the n numbers. Target left is going to be 0 to target, or 0 to t, just for short, because I'm lazy. And so then total number of inputs is going to be n times t, because they're kind of moving in different parallels. It's a little bit better than that because there are a lot of unreachable states. This is actually one of those cases where top down it may be slightly better. they're overhead with Python and top down and function calling. So I'm kind of, you know, if you want to be pedantic, there's some more trade-offs there, but I'm not going to go over that. But yeah, that's number of inputs, and each input takes all of k time and all of one space. So that means that this is going to be all of n times t times k time and all of n times t space. And that's pretty much it. Yeah, that's what I have for this one. Let me know what you think. And yeah, I don't know, but that's all I have for this one. Yeah, happy holidays, happy new year, happy everything. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.